Alright, so today we're going to be talking about the properties of logarithms. So you should have your notes pages, and so we're going to go through them. It shouldn't take too long. Okay, so first thing that I want to remind you of, so I have set a light bulb here, is that logarithms represent exponents. Okay, so the properties of logs are going to parallel the properties of exponents. So there are three major rules, and then we're going to talk about the change of base formula to remember. So the first one is the product property of logs, which says that if we have the log base b of m times n, it becomes the log base b of m plus the log base b of n. And the reason I point out that we're going to parallel that to our rules of exponents is, if you think about it, when we multiply powers, with the same base, we are going to add their exponents. So if you think about logs as exponents, a log base b of m times n can be split to the log base b of m plus the log base b of n. Okay, similarly, we're going to look at the quotient property of logs, which says that the log of sum base b of m divided by n can be rewritten and split as the log base b of m minus the log base b of n. And again, if you think about when we multiply powers, or similar to when we multiply powers, if you divide powers with the same base, back when we did our exponent rules, we subtracted the exponents. So same type of rules apply. Okay, if you think about, again, logs as exponents, then it makes sense that multiplying exponents you can split with addition, and dividing exponents, or dividing logarithms, you can split through subtraction. Okay, so the last one that we've got to remember is the power property of logs. And the power property of logs says that if we have log base b of m to the n power, you can take that n and put it out in front and turn it into n times the log base b of n. Now, which is kind of like power to a power you multiply, so you can take this power and you can multiply it out in front. Okay, but again, rules of logarithms say if you have a power inside a log, you can take the exponent and multiply it to the outside. Okay, the last thing that we're going to put on this page before we go and work a few problems is something called the change of base formula. Okay, the change of base formula says that if we have some log base b of m, you can change the base to whatever you want, and you can make it log some base we'll call c of m, which is the big number, and divide it by log base c of b. And the reason that this is useful is if you use the change of base formula, so if you use change of base formula with a base of 10, which is called the common log, you can use a calculator. Again, in the calculator, there is a log button. So you can use the calculator log to simplify. And which is one of the main reasons. So a lot of times we'll use base 10. There's another one that has a base of e, which we're not quite to yet. So for now, when we talk about change of base formula, we're going to make everything a common log, which is a base of 10. Again, the purpose of this, for now, is so that we can put these problems in a calculator. Okay, so with that, we're going to work a couple of problems. And practicing this. So we are on to page 2. Okay, and the first couple things that you're going to be asked to do is to expand our logarithm. So all we're doing right now is practicing our rules. So if you look, we have log base 5 of 25 times x divided by y. So I'm going to split this into 2 parts. And for the first couple, I'll go a little bit slower. So I'm going to write this as the log base 5, 25x. And we want to make this division problem 2 separate problems. So then I'm going to write, okay, the log base 5 of y. If you go back to your rules, we said we can split division with a subtraction. This becomes the log base 5 of 25x minus log base 5 of y. And if you look, we now have a 25 times x. So I'm going to do the same thing again. I've got the log base 5 of 25, and we said to split multiplication, we're going to use addition. So plus the log base 5 of x, and still minus the log base 5 of y. And usually at this point we can circle and move on. The only thing we've got to check on if they're ever just numbers. So this piece right here, log base 5 of 25. You've got to ask the question, can we rewrite this as a single number and write our answer without the log? So mentally, the way we check that is we're going to talk about what does a log mean. So what this is saying, you remember from the other day, is 5 to what power equals 25. Okay, and we know that 5 to the second power is equal to 25. So this whole piece, log base 5 of 25, turns into the number 2. Everything else is going to stay the same. So we've got 2 plus the log base 5 of x minus the log base 5 of y, and we can circle it. Okay, which leads us to the second one. The second one, we don't have division. You see how we have multiplication? So I'm going to go ahead and split this. We've got 3 pieces this time. We've got the log base 3 of 27 plus the log base 3 of x to the 5th, again, multiplication. So we have another plus log base 5 of g. Okay, so there's a first step. Second step is we're going to look and see if we can take any of these pieces further. So again, I have a log base 3 of 27 here. And we're going to ask, okay, the log base 3 of 27 is like saying 3 to what power is equal to 27. And 3 times 3 is 9, and 9 times 3 is 27. So 3 to the third power is equal to 27. Right, so the second thing I notice is that there is an exponent here in the second piece. So the second piece, we said when it comes to exponents, we can take the exponent and we can put it out in front. So instead of log base 3 of x to the 5th, this is going to become 5 log base 3 of x. And then the last piece There's nothing else we can do with that, so we're just going to leave it plus the log base 5 of g, and we are done with that one. Again, all we're doing is practicing our properties of logs, so right now we are expanding. Okay, so the very last one in this section right here, expand. I can go a little bit faster. First thing to note is there's a little imaginary 10 here. If you don't see a base, we call it a common log, and it's a base of 10. And once you kind of get the hang of it, you can go a little bit faster. So I'm going to go through this time and I'm going to say, okay, I have a log base 4. And if you look here, since we're multiplying by x, log of 4, not base 4, or log of 4. Since we're multiplying by x, I'm going to put a plus log of x. And since we're dividing, I'm going to put a minus the log of y to the second. And this one's almost done. The only thing we've got to check for is if we have this exponent here. So this 2 can now go out in front. So my final answer is log of 4 plus the log of x minus 2 log of y. Okay. So the next couple are going to ask you to simplify or possibly combine. So it's the same idea, but we're now going the other direction. So okay, simplify. We've got log base 4 of 32 minus log base 4 of 2. This time we are split with subtraction, which means to bring these together, we are going to divide. So this becomes the log base 4 of 32 divided by 2, which is the log base 4 of 16. And sometimes you'll be done, but again, before you move on, you're going to ask the question, okay, what does that really mean? And that means 4 to what power is equal to 16? We know that 4 to the second power is 16. So I can replace log base 4 of 16 with the number 2. So my final answer is 2. Okay, over here with part B, same idea. First thing I notice is there's a 2 out in front. So when we go the other way, this 2 becomes the exponent. So this is really log base 2 of 5x minus log base 2. If I square 3, I get 9, and if I square x, I get x squared. Okay, so what I did is I took 3x to the second power, and I moved the 2 from the front. Okay, so then I have a subtraction, and similar to the one over here, when we merge subtraction, we are going to divide. So this becomes the log base 2 of 5x divided by 9x to the second. And again, we're done here if this fraction doesn't simplify, but we have an x on top and an x on the bottom that we can cancel. So my final answer is going to be log base 2. If I cancel one of those x's, I'm left with 5 in the top and just a 9x in the bottom. Okay, so there's my final answer. Again, I'm just doing what we did in this first problem, but we're going the other way. Okay, so this one over here to the right is very, very similar. First thing I notice, there are 2 numbers out in front. So I'm going to go ahead and remind you, numbers out in front become the exponents. So this is log base 2 of x to the 6th plus log base 2 of y to the 5th. This time we have an addition sign, and we said to merge addition, we are going to multiply. So to bring these together, I've got log base 2 of x to the 6th times y to the 5th, and then I am done with that. All right. So then we're going to go back to the first type of problem, which says expand. And I know you have one like this on your homework, so I wanted to take a second to add it. So what I want to remind you of is the square root of y. You go back to chapter 6, where we have log base 4 of 5. This x, square root of x, excuse me, is the same as x to the 1/2. And there's an imaginary 2 here. And we said if we rewrite radicals as exponents, then they become fractions. The reason that helps us is now we can expand this. So the first thing I noticed is it's 5 times x. And we said to split multiplication, we're going to add. We have log base 4 of 5 plus the log base 4 of x to the 1/2. Okay, now the final step is we can get rid of that exponent. So we said that exponents, right, come out in front. So what we're going to end up with as our final answer, we still have the log base 4 of 5 plus the 1/2 comes out in front, and then we have the log base 4 of x, and we are done. And now let's talk about this log base 4 of 5 for just a second, because I'm kind of skipping over it, but what this is saying is 4 to what power equals 5? And since that's something that we can't really answer, we don't worry about it and we just leave it as log base 4 of 5. We're only going to replace it if it becomes a whole number, so something that we can do pretty quickly. Okay, we've just got a couple more. Again, we're going to go back to write as a single log, which is now going the other way. I'm going to merge all of these things. And this time I'm going to go a little bit quicker, because I'm hoping that we're starting to get the hang of it. The first thing I'm going to write is log base 7. And I noticed a plus. So plus says to merge these, I'm going to multiply. So I have x times y. The minus tells me I'm going to divide. So I'm going to divide by z. And the last thing, there's this 2 out in front, and we said the 2 out in front becomes the exponent. So instead of dividing by z, I'm going to divide by z to the second. And that problem is now complete. Okay, similarly, I'll work this one first because it's a little bit less complicated. All I need y'all to get from this is we said to merge addition, you are going to multiply. So log of 7 plus log of 2 is really the log of 7 times 2. And 7 times 2 is the log of 14. And the reason we're done there and we don't keep going is because this is saying 10 to what power gives you 14. And since that's something that we can't answer easily, we're just going to leave it log of 14. Okay, so last complicated one. We have log base 4 of 10 minus log base 4 of y plus log base 4 of z. So I'm going to start here. The log base 4 of y plus log base 4 of z becomes log base 4 of y times z. So I'm going to leave this. Okay, so we have log base 4 of 10 now minus log base 4 of yz. Phase 2 of this problem is now to merge the subtraction. We said to merge the subtraction, we are going to divide. So this becomes log base 4 of 10 divided by yz. And we are now done. Okay, so the last couple on here are calculator problems. Okay, change of base formula. And we said there are other uses for it, okay? But for what I want you to get out of this for now, we're going to use change of base formula for now to be able to answer some of these in a calculator. We've got log base 81 of 27. And the way that we're going to use this, we're going to make these logarithm problems the common log or a log with the base 10. This becomes log over log. The big number stays in the top, so log of 27. The little number goes to the bottom. Okay, this is now something that you input in the calculator. My caution to you is make sure, depending on your calculator, you hold your parentheses. So when you do this, you're going to do parentheses, log of 27. And a side note, there is a log button, L-O-G. You're then going to do divided by, parentheses, the log of 81. So I'll get my calculator real quick and I'll show you what this kind of looks like. Let's see. Okay, so when I do this, again, I'm going to do, for this calculator, I think you do 27 log, you get an answer, divided by, parentheses, 81 log, close my parentheses, hit enter. I get 0.75. Okay, so the answer to this first one, okay, 0.75. If it doesn't accept that answer, then we're going to give our answer as a, I was looking to see if they have it, as a fraction. We know that 0.75 is equivalent to 3/4. So either you can do 0.75, 75 hundredths, or you can do 3/4, depending on what it wants. Okay, so this last one, same thing, we're using change of base formula, so we're going to turn this into a common log. We've got log over log. The big number, 36, stays in the numerator. The small number, 5, stays in the denominator. This time, it's not going to give us a perfect answer, so we're going to round to 3 decimal places. Okay, so again, let's find this calculator. As you can see it, I'm going to go 36 log divided by, and when I do divided by, I've got to hit parentheses, 5 log. Some of y'all, you'll do log first, then the 5, close parentheses, and you'll hit enter. And this time I get about 2.227. If we're rounding to 3 decimal places, so my answer is approximately 2.227. And read the directions on your Math Excel to tell you what to round to. Okay, but this is one we can't answer. 5 to what power gives us 36, right? So again, because it's a decimal, 2.227, so we're not going to do it in our head. We're not going to do it by hand. We're going to use a calculator to help us figure that out. Okay, so that concludes your notes. Okay, for your homework, there is a 7.4 Math Excel. Y'all remember to message me if you have any questions, and I wish you all luck.